My name is Mike Ensor. I work for Google. The original architect of what we now know as the small form factor distributed cloud, GDC. Integral efforts and work doing with McDonald's started that about 4-ish years ago, and we just saw that at the keynote that it was announced that McDonald's now working with us. A lot of that kind of came from this edge. So what I'm going to do is I'm going to talk about, if you imagine McDonald's is 40,000 locations, that's not an easy way to start distributing software. That's going to take a lot of effort and forethought into how to deliver software at that kind of a scale. But because I work for Google, we have to use the word AI in front of everything. So what I'm going to do is I'm going to basically walk through basically what we think about, how we approach it, how we need to automate it, and then what we need to think about for like categorization. So this is maybe a little bit of a, I don't know, I'm just going to be blunt about it. AI is just software at the end of the day. It's just bits and bytes. It's a package of software you put on. It's got inputs, it's got outputs, it's just software, right? So we need to treat it exactly the same. So when we think about our AI models that we're putting together, whether they're machine learning models, whether they're LLMs, whether they're fine-tuned, doesn't really matter what that package of software is, it's just software. We definitely need to think about using SymVar. We need to go through and make sure that we have major, minor, and patches. Thinking about that as differentiating on a patch is something where, oops, I maybe have a small defect I want to improve on my model, or in my software, same thing. A minor would be, let's add new classifiers, or maybe I'm now looking for new items that need to exist in my model. That would be more of a kind of a minor. And a major would be, we're going to either have major deprecations or major additions and functionality change. Second thing is, thinking about your AI, think about it like CI/CD. It's no different. We always call it ML ops, but oftentimes that kind of gets lost in a whole bunch of framework conversations. At the end of the day, treat it just like continuous delivery. I actually build all of my models. I don't use anything super special. I'll use pipelines to make it a little more efficient, but everything that I build is usually CI/CD based. So I do composite-based CI/CD pipelines and things along those lines. Third is creating continuous test feedback. Again, this is just software. If we think and treat it the same way, remember that as you're making a model, as you're designing something, you want to have some way to always test it. And this isn't the 70, 30, 10 tests that you would do for training a model. This is actually put it into an environment and do some sort of a test against that automated of some sort, make sure that you are getting the qualifications back. Also, when it's out in production, this is a good time to mention, take 10% of all of your queries in and out of your model and save those. Save what you think the response is, but also what the question is and the context around it. Use that to feedback in your model so you can fine tune it further. When you get into a widely distributed scenario, that can be a lot of information, so definitely make that configurable, because 10% of 40,000 locations running a couple hundred a minute, that's a lot of data. So maybe tune it down to a couple percentage points. And last thing is embracing interfaces. For everything you do on your entire systems, anywhere you're at, always think about interfaces. Interfaces being APIs, they might be strictly defined documentation saying this system will talk to this system this way or whatnot. Be very, very specific about those. Every API I put in front, I put an API in front of every single model and ML process that I work with. And that's just good software development practice. So the way that I typically set up one of these from a machine learning model perspective is training up in the cloud, because the cloud's going to have a lot more efficient use of resources and technology to do that with. It'll be more elastic. But effectively, do your training. I'm using Vertex pipelines. That's one of our tools that we have at Google. When I'm done with that model, I actually export it out into a GCS bucket. That's my interface for how I deploy this out to anything else. That GCS bucket, everything goes in there. I have a defined set of folders and structures within that GCS bucket to hold the versions and the names and the feedback that I get from my models. So that's my interface. You don't even have to write a full application, that's just a bucket. So then on the other side, I actually can tell my end locations to say, reach up and pull down that configuration from that cloud. Pull it down into something local. And this is where, again, we're with Rakuten here, like this is where the software-defined storage comes on that. I pull it down locally, put it into a PVC. Now when I load up my application, my inferencing service, it just pulls straight up from that configuration. So then I create another last little feedback about every, said 10%, 5%, 3% of those queries will end up going back up into my cloud, where I then do more analysis back and say, was this successful, was I not? How do I make my next version of my model, things like that. Next thing is automation is absolutely required. Do not try to attempt anything at human scale when you're looking at anything beyond a couple dozen at most. Everything needs to be automated. What I mean by that is, if we have an operations team and you've got a whole bunch of locations you want to deploy these things to, humans can log in, make changes, and that works for so long. inevitably this is what ends up happening. You create a whole bunch of tmuxes, or you have a whole bunch of shells, or you start throwing in configuration management tools in order to say, hey, let me continue to keep pushing this. What ends up happening is on this operator side, the operator team now owns every bit of that state. Did it succeed? Did it fail? Was it retriable? Was it partially done? Like, was it a security? Was it a network? Like, all of that state ends up happening. A couple dozen, not a big deal. A couple thousand, that now becomes a massive amount of information you have to hold on to. So push-based configuration becomes quite difficult. So from an automation, this is where GitOps really comes in very strong. So GitOps, one, you're using interfaces to your clusters or to your configuration for what you're deploying to, but you're able to push all of that state into a repository. Now, asynchronously from that, each of those locations will reach up and pull that configuration down locally and become consistent. That means that if you look at the entirety of the system, if I've got a McDonald's, I've got 40,000 locations, I have 40,000 or 130,000 machines that now have the ability to do something for me, whereas I only have 10, 20 people, maybe globally able to do something, right? So all the compute's on the other side. So I want to put it into a desired state, have that system reach up, pull that down, be consistent when it hits the ability to hit the internet and pull it down. Now that's where all my compute actually happens. So that being said, focus on the concept of desired state. If this is new to you, definitely look it up and follow through it. If not, the concept of a desired state or using that is absolutely imperative at this kind of a scale. This means that I will tell that machine's going to look like this. It will always be in that state for as long as it possibly can until such time that we make a change to that. This helps us a whole lot in the event that we have network outages or we have systems starting to go rogue. Maybe you threw on a CRD that then had an operator that all of a sudden started spawning up a whole bunch of pods that you didn't want. Then this reconciliation loop that gets created will keep that thing back down. So it manages drift management in a loose way. You can kind of say it helps with some security aspects of that if you do get compromised in that drift management. If it's not in the desired state, the system will say, nope, that pod's not supposed to be there, let's kill it and keep it in. So loosely, I'm not gonna claim that is a security feature, but it's a good, healthy piece to have with it. So then the reconciliation of these desired states, make sure that what you're doing in these have to be a declarative state, it cannot be an imperative state. So get comfortable with the idea of eventual consistency because you're going to go set that state and be like, hey, it will get there. And if it doesn't, you'll deal with the deviations from that. It needs to be idempotent. So if I apply that reconciliation loop only works if you have an idempotent system. And the last one is using some sort of a config management tool. We at Google, where config sync is the name of our tool. That's ours. It's a kind of closer akin to being a Flux than it is to an Argo. Argo is really good for intra-cluster. It's not as great. It still will work, but not as great and has some challenges for scale at a very, very broad fleet level. Our tool was designed originally to be a fleet-based tool. So I'm dealing with thousands of clusters. How do I do deployments when I'm looking at, I want 1% of my deployments to go to a subset of all my clusters, then 20, then 50, then 100. I can do that kind of an automation to going across those things. So then desired benefits you get out of this here from using configuration sync is one, it generally plugs in with most of your KRM from Kubernetes. No big real change there. Preventing that drift management is really important, especially when you lose internet. At our McDonald's, we have to guarantee that those systems are up without internet for 7 days straight minimum. And so this gives us the ability to still manage, maintain the cluster, be healthy, and do some self-healing in that event. All right, and then the last bit here, this is maybe a little bit net new because I don't think we talk about this a whole lot in software development, but you need to become really good at labeling and taxonomy. It is actually a science. There are people who have PhDs in taxonomy and labeling sciences. Typically they're in the librarian family of things, but one, think about what are generally called facets. Facets are something that you can make a decision on. You can make, it's a pivot point in the pieces of data you have. Facets are essentially just functions. So think the function of the thing that you're working with. So it might be labels of, it could be an operating system like Linux, Windows, what have you. Licenses, is it open source, is it not, whatever, et cetera, right? So those are the idea of like facets. This is a non-exhaustive list. When you think about labeling your things, you have to start thinking about how you structure those together. Next is coming up with a common language, especially if you have a really large organization you work with then, come up with a common language. Whatever your corporate speak is or whatever words you want to use, make sure they're consistent, publish it. Be very, very distinct about this because if you have one division of your organization saying, oh, we call them deployments, another one say, oh, we call them applications, those might sound quite differently when you're talking to different people. So make sure you know what those words are. Don't be afraid to create what's called a DSL or domain-specific language, where it's your company and your organization has a specific term and a name for something so that we don't get confused. Humans If we get rid of all the humans, all this stuff goes away. So us pesky humans make things difficult. So we got to make those languages really work. All right, next one is thinking about hierarchy and topologies. When you're putting together these label structures, a flat label structure does kind of work, and that's usually how it's implemented out as a flat, but there's an inherent hierarchy that gets put into that. So think about geographical locations are typically something you want to like make a decision on. It might be organizational structures, might be just organic growth where I have divisions and teams or applications, might be types of applications. Those are things we think about, like what makes a hierarchy happen. And this is so when I go to make a deployment, an example being, I want to play a new point of sales version to the entire global fleet of everything at McDonald's. I'm not going to just say, oh, 40,000 get this. I'm going to start with a series of these already predefined geographical topologies. I'm going to use these functions over here to say, I will go to stores that are first movers or are willing to have, a facet might be, they're willing to be an early entry store, things along that. My next facet might be, hey, they're a normal customer, and the last might be they're a last mover, right? That's a facet that I can create. I can make decisions on the entirety of the fleet, but break it down by geographical and then my facets. And then last is plan for change. So in all of your labels, you're not going to come out on day one, and I definitely do not recommend sitting down for months at a time, coming up with a perfect labeling system, because the moment you use it, it'll be useless. So organically grow it and plan for the idea that you're going to have names of labels that are going to change. Think about things like following software development practices, 3-cycle deprecations. I'm no longer going to use that label after 3 iterations of use, or 5 or 10, or some date. So think about that, make sure that's published. Then as you roll it off, think about those are the breaking changes after a long period. If not, it's additive. So plan for change as you're going through the whole thing. So just as a quick summary, again, I can generally do most of these talks in an hour on each of them, but I got limited time, and they gave me a microphone, so I'm going to use as much as I can. Anyway, AI is just software, so just remember that. It's just bits and bytes at the end of the day. Even though it does something magical and cool, it's just bits and bytes, so treat it as such. Second is automation is required. Do not try to attempt large scale at a human scale. It just will not work. I highly suggest anything above a couple dozen of anything in software, look at pull-based configurations over push-based. Again, be comfortable with the side effects of that. It's not a magic bullet. There are things that will come out of there that aren't going to be easy, but plan for it and design around it because it's at better scale. And last is become good at labels. Understand how to label your items, how to label your systems, things like that. Software, your models, your everything. So, and that is it. So thank you.